Hi, in this lecture I want to continue our discussion of the prisoner's dilemma, and I want to focus on how we get cooperation in the prisoner's dilemma. And I'm going to highlight 7 ways that scholars have identified that cooperation can emerge in a prisoner's dilemma even though it's in no one's individual interest to cooperate necessarily. Now remember, in the prisoner's dilemma it looks as follows. You've got 2 players, player 1, player 2, and each one has 2 actions. They can cooperate or they can defect. It's in our collective interest to have us both cooperate. We both get a payoff of 4. But individually, since 6 is bigger than 4 and 2 is bigger than 0, it's always in each player's interest to defect. But if we both defect, we both get payoffs of 2, which is worse than if we both cooperate. So individual interests don't line up with collective interest. So the individual incentives point us towards defecting. Collectively, we'd like to cooperate. So how do we get that cooperation? So to analyze that, I want to move to a somewhat simpler model. I'm going to assume that what happens is now is each person just has an action they can take. And if they take that action, it has some cost and some benefits. So I'm assuming that if I cooperate, that has a cost to me of C. But it has a benefit to the person I'm playing with of B. And I'm further going to assume that their benefit is larger than my cost. So therefore, socially, we'd like me to cooperate because the other person's benefit is larger than my cost. Individually, I'd like to not cooperate because my cost is positive. So this captures the essence, really, of a prisoner's dilemma, right? Individually, I'd rather not cooperate. Socially, everyone would prefer if I do cooperate. So in this simpler setting, I want to talk about the different ways in which we can get cooperation. I want to start by talking about some work by Martin Nowak. Now, Martin has this wonderful book called Super Cooperators, where he goes in much more detail about these different mechanisms. So the language I'm going to use comes from his book. The first way in which we can get cooperation in something like a prisoner's dilemma is through repetition. Now, Nowak refers to this as direct reciprocity. What does he mean by that? What he means is we're going to play this game many times. And so if we're going to play this game many times, I can recognize maybe it's in my interest to cooperate now because when we meet next time, we'll cooperate in the future. So my colleague Bob Axelrod has a very simple strategy that can induce cooperation in the prisoner's dilemma called tit for tat. We both start out cooperating, and as long as the other person keeps cooperating, we cooperate. If that person ever defects, then I defect. And this very simple strategy can keep us both cooperating, provided we meet often enough. And that's the essence of direct reciprocity. Let's see why. So let's let P be the probability that we meet again. And let's let 0 be our payoff if we deviate. And then what's my payoff if I cooperate? Well, if I cooperate, it's going to cost me C. However, if I'm going to meet you later, there's some probability of meeting you later, and when you meet later, you can cooperate with me, then later I'll get a payoff of B. So my payoff isn't just minus C from defecting, it's minus C plus P times the benefit if we meet again. So if that ends up being positive, what that means is that I should probably cooperate. And we can rewrite that as just saying as long as the probability of meeting is bigger than C over B, then cooperation should emerge in the prisoner's dilemma. Let me give an example from my life that sort of explains how this works. I used to live in Los Angeles, which is a huge city, Pasadena actually. And then we moved, my wife and I moved to Iowa City. And one of the first days I was in Iowa was in the grocery store and I was just buying a couple items. The woman in front of me in the grocery store had a cart full of food. And she said to me, "Why don't you go ahead?" Now I was shocked because in LA no one ever let me jump ahead of them in line at the grocery store, no matter how much stuff they had in their carts. But the reason why she did this is not because people in Iowa are intrinsically nicer than the people in LA. It's because of the fact that she knew she was likely to meet me again because Iowa City was a small town. So let's see how that works. It's just direct reciprocity. So let's suppose that the benefit to me of getting to jump in front of her was 10 because she had this cart full of food. Let's suppose the cost to her is only 2 because I only had a few items. So this ratio of cost to benefits is 1 over 5. Well, now the question is, what's her likelihood of meeting me again? Well, in a place like Los Angeles, if we're at the same grocery store, it could be maybe 1 in 1,000. It's not very big. But in a town like Iowa City, there might be a 50% chance she's going to see me again because it's not a very big town. So given that she's likely to see me again, in Iowa City, she's going to cooperate. In LA, she's not going to cooperate. She has a greater likelihood of direct reciprocity, and that direct reciprocity leads to cooperation. What's another method? Reputation. Now, Nowak calls this indirect reciprocity, because the idea behind reputation is as follows. Instead of us directly meeting again, Maybe I know and I get to know the woman who was in front of me in the grocery store, and I tell other people how nice she is. So she gets a reputation. So now what we can do is we can say, let's let Q, instead of it being the probability that we meet again, let it be the probability that her reputation gets out. And so what's going to happen is, now the cost of her to letting me go ahead is C. Her benefit is Q, the probability that her reputation gets known, times B. Because if her reputation is known that she's a nice person, other people will cooperate with her because they know she's going to cooperate with them or possibly someone else. So creating this sort of virtuous cycle of people cooperating with one another. So again, we get the same sort of inequality. As long as the probability for reputation being known is bigger than that ratio C over B, we're going to get cooperation. So notice the subtle difference. In direct reciprocity, I'm cooperating because I'm going to meet you again, and I think I'm going to get a payoff from you. In indirect reciprocity, I'm hoping to get a reputation, a good reputation, and I'm hoping that person will spread far and wide how cooperative I am. And then when somebody else meets me, they'll say, oh, there's Scott, he's cooperative. I'll cooperate with him because he's such a nice person. And through indirect relationships, we can induce cooperation. Here's a third, network reciprocity. So let's suppose that we've got a set of cells in a network, and we want to ask, will those cells cooperate with one another? Is it in their interest to cooperate with one another? What I'm going to do is I'm going to consider just a very regular graph. Remember, some networks, we had all these different types of networks. A regular graph is one where everybody has the same number of neighbors. What we're going to see is if each person has k neighbors, if k is less than b over c, we're seeing that same ratio again, then what we're likely to get is cooperation. Let's see why. In this setting, I'm going to make a different assumption about behavior. What I'm going to assume is that people are networks, and they decide what behavior to follow based on how successful their neighbors are. So let's think of a simple network where the benefit of having somebody cooperate from you is 5. The cost of cooperating is 2. And again, here each person is connected to 2 people. So red is going to denote defectors, and green is going to denote cooperators. So with this long line of people. If you're a defector right here surrounded by 2 defectors, your payoff is going to be 0, because you're neither cooperating nor is anybody who's playing against you cooperating, so your payoff is just a flat rate of 0. If you're over here and you're a cooperator and you're playing with 2 cooperators, your payoff is going to be 6. Why is that? You're going to get plus 5 from each of the 2 people playing with you, but you're playing 2 for cooperating with each of those, so that gives you a payoff of 6. So now we have to think about this person sitting here in the center, that's on the edge between defectors and cooperators. What are they going to do? Well, they're going to look at the defector to their left. They're going to say, this person isn't cooperating with anybody, so it's not costing them anything. I'm cooperating with them, so they're getting a payoff of 5. This person to my right is getting a payoff of 6, as we talked about before. So when we look at this person in the center, they're deciding if I defect, I might only get 5, but if I cooperate, that person's getting 6. So their impressions are going to be that cooperating is better than defecting, so they're going to cooperate. Let's change the payoff. Let's suppose that the cost of cooperating is 3. Well, now the payoffs to the defectors are going to be unchanged because they're not cooperating with anybody. But the payoffs to the cooperators are going to fall by 2. Before they were 6, but now they're going to be 4. And let's see why that's true. Remember, they're cooperating with 2 people, and 2 people are cooperating with them. So that means they're getting 2 benefits of 5, but they're getting 2 costs of 3, and we add that up, we get 4. Well, now when this person looks to their right and their left, they're going to see that, well, the defectors look like they're doing better, and so this person is going to switch and defect. Now we can do more elaborate models. Let's suppose we now have k equal 4, so each person is playing against 4 people. So this person is playing against 4 people as follows. Again, if this person is defecting and all their friends are defecting, their payoff is going to be 0. And if we look at someone over here who's a cooperator, let's suppose that all 4 of their friends are cooperating, we can figure out their payoff as well, and they're going to get 4 times 5, and they're going to get 4 times minus 2. So that's 20, that's minus 8, so the payoff is 12. So if you look at this person right here, their payoff is 7, but if they look at the cooperators they see, wow, these people are getting 12. If they look at the one defector they see this person's getting 15, and they're going to defect. So what's interesting here is the benefits are 5, the costs are 2, and this person wants to defect, whereas previously when we had the benefits are 5, costs are 2, but we were less connected, we only had 2 neighbors, you wanted to cooperate. So we see as you get more connected, you have incentives to defect. Let's see why we get this k less than b over c. And the way to think about that is we want to think about this one defector who's sort of sticking out, who's in the midst of all these cooperators. Supposing, John, you've got k neighbors. Let's suppose you're surrounded by cooperators. What's your payoff going to be? It's going to be k times the quantity B minus C. Because everybody cooperates with you, so you're getting K times B, but you're cooperating with everybody else, so you're losing K times C. Let's suppose you're a boundary defector. So you're somebody defecting who's surrounded by cooperators. Well, then your payoff is going to be K minus 1. Those are all your other neighbors that are cooperating with you, times B. Now, let's look at when this is going to be true. When is K times B minus C going to be bigger than K minus 1 times B? Well, if we just do the math, we're going to get B over C has got to be bigger than K. And so what we get is we get that this is the inequality we get, that K's got to be less than B over C. So again, very simple mathematics explains what's going to be necessary for cooperation. Now, quick aside, when we think about reputation, we'd like to have a really dense network because our reputation is more likely to spread. When we think about this network reciprocity story, we'd like to have a less dense network because there's less of an incentive to defect. So whether you want a rich network with lots of connections with high degree and high clustering coefficient, or whether you'd like a sparse network, depends on the mechanism you're using to get cooperation. If you're relying on reputation, you want lots of clusters, lots of connections. If you're relying on network reciprocity, you'd prefer it to be starker. Next, group selection. Group selection refers to the fact that it could be that the selection is on groups of people as opposed to individuals, and so groups of cooperators can win out. Here's the idea. Suppose you've got two groups of people. There's a red group here, and there's a blue group here. And each group has to, within itself, has some percentage of cooperators. So let's suppose the red group has 80% cooperators. And let's suppose the blue group has only 50% cooperators. Now let's suppose that the red group and the blue group go to war. Well, who's likely to win? The red group is likely to win because they've got more cooperators, and they've got more cooperators, and over time they've benefited more. They probably have more food, they probably have better technology, they've probably got all sorts of stuff. So when you think about going to war, groups of cooperators are likely to beat groups of defectors. So what's going to happen is, even though it's the case that within the group, defectors will do better, when those groups go to war against each other, groups that have more cooperators are likely to win. And so what you get is that by selection at the group level, if there's competition between these groups, as long as it's frequent enough, then you could actually get a force towards cooperation. Last, we have kin selection. In kin selection, the idea is this, is that different members of a species have different amounts of relatedness. And so if someone's my brother or my offspring or second cousin, I may actually care about their benefit. So what we formally do is we have some measure of relatedness R. So for a child, that relatedness would be a half genetically. So if I can do something that benefits my child 10 and only costs me 2, maybe it's not the case I'm just saying 10 is bigger than 2. If I were purely selfless, that'd be the case. But if I just take into account genetic relatedness, then I'm just saying, is 5 bigger than 2? This particular model has been used a lot in ecology because you have some species like ants and bees where R is really, really high, and it's not surprising that within those species you see lots of cooperation. Okay, those are the sort of 5 general ways. Let's talk about 2 ways we can get cooperation in human societies. First one is laws and prohibitions. You can just make things illegal. So for example, it might be my interest to talk on the cell phone when I'm driving, but it's not in society's interest because it increases the probability that somebody else is going to get injured. So we pass laws saying it's not legal to talk on your cell phone when you're driving. Another thing we can do is we can create incentives. So when I lived in Madison, Wisconsin, oftentimes it would snow a lot, and there was a law saying that 24 hours after the snow had stopped, you had to have your sidewalk shoveled. Now the cost of shoveling my sidewalk was high for me, but other people were going to benefit. And they would benefit more than it cost me to shovel. In order to induce me to do it, the city basically said, if you don't shovel it, you're going to have to pay a huge cost. You're going to have to pay $100. And that fear of paying the $100 made me shovel my walk. So simple incentives. It wasn't illegal. I didn't have to shovel my walk. I was just going to have to pay a fine if I didn't. Okay, so you've seen a whole bunch of ways in which we can get cooperation in the prisoner's dilemma. It can be repeated, direct reciprocity. It can be reputation, indirect reciprocity. It can be a network effect. It can be group selection, where groups fight against each other, and so the groups that cooperate are likely to win. There can be kin selection, where what happens is that I cooperate with people who are like me. And then finally, we can have things like laws just prohibiting things that aren't good, and we can have incentive structures where we pay people to cooperate when they naturally be led to defect. Okay, so that's the prisoner's dilemma and how we can solve it. But that's a simple 2-by-2 interaction. Where we want to go next is we want to talk about larger prisoner's dilemmas where there's lots of players. And these are sometimes called collective action problems. Okay, let's move on. Thank you.